Okay, so if we look back at what we learned already with the protons and electrons coming from the atomic number, and now we're going to look at the number of neutrons. Our mass of an atom is mainly made of the protons and neutrons. The atomic number will give us the number of protons. So in order for us to calculate or find the number of neutrons in an atom, we need to take the difference between the mass number and the atomic number. Now most of the mass numbers that are given on a periodic table have a decimal point to them. Simply round these numbers to find the mass number and then subtract the atomic number from that for our number of neutrons. So if we look over at oxygen, with oxygen having an atomic number of 8 and a mass number of 15.999, we need to round that to 16. So by doing so, we get 16 minus 8. That will give us 8 neutrons. Now if we look over here, say at calcium, again that would be a mass of 40 and an atomic number of 20. And 40 minus 20 would be 20. Now not every single one of your elements is going to have ones that are going to be exactly the same, protons and neutrons. So for one that doesn't have that, let's look right here at lithium. Lithium is going to have a mass number of 7, because 6.9 rounds to 7, and our atomic number is 3. And 7 minus 3 is 4. Lithium has 3 protons, 3 electrons, and 4 neutrons. Okay, here we have our periodic table. We're going to be discussing the characteristics and distinguishing a metal or nonmetal based on the melting point on the periodic table of the elements. Here we have, on the left-hand side, elements that have relatively high melting points. Magnesium was 650, barium was 727. If we go across and we look over here, we have iodine with 113, or xenon with negative 111, or even go higher with oxygen just negative 218. We can see that there's a distinct difference from the left-hand side to the right-hand side of our periodic table. That right there gives us a distinct point here in the middle of a diagonal line that shows metals on the left-hand side with large melting points and nonmetals on the right-hand side with relatively low melting points. This is a very easy way for us to distinguish metal versus nonmetals. For example, if you look at calcium, 842 degrees Celsius melting point, I would consider that to be a high melting point. And if we look at sulfur with 115, that would be a lower melting point. Even lower would be oxygen at negative 218. That would be nonmetals.